All right, Happy New Year. Last year we were looking at MVC and we were specifically looking at the model part of that, implementing domain models basically, so how we specify the data structures for our applications before we move on to looking at controllers. I think I put up a screencast that was missing 10 minutes at the end that dealt with has many associations, so I just wanted to try and fill in some of those gaps and do a quick recap of the domain modeling part that we've been doing. If you remember, there's an account on GitHub, ACESII, and there's a project in there called eRegister. On there are some branches, so there's a lectures branch, a Monday and a Wednesday branch. The lectures branch is the canonical branch, if you like, the one that you need to look at. And I'm just going to check this project out now. So what I've done is I've implemented the domain model. So all the work that you've been doing in class, I've done the same, and I've checked it into Git. If I use gedit here, we can have a quick look. Oh, that's all right. Maybe that's better. Okay. Oops. Sorry about that. I'll just close all these hangovers from before. Sorry. Okay, so Grails app domain UK. So if you remember, we put them in this package, and here are the 7 properties in our domain. Oh, sorry, 7 objects in our domain model. If you remember them, there were a number of different property types. So we've got simple scalar values, if you like. Here we've got course name defined as a string, and we've got course code and description. If I wanted an integer property, I could say int, I don't know, my int prop. I'm going to give it a value of 1. So I save that, and what I'll do is if I do a Grails run app here, I've added some comments, so you can look through my domain model and see how it tallies with yours. I've added some other features that I'm going to describe to you as well. Let's have a look how this is going. Okay, so we've got a running message, and in a second it should say browse to a particular port. Obviously we're not particularly interested in the web application itself at the moment, because we're more interested in the database at this stage. Here I've got a database session. You'll see I just did a show tables before, empty database, but now that I've run the application, we've got all these tables generated for us, and it was course. We just added my int prop to course. So if I describe course, you'll see that I've got my int prop now, which is an int 11. So I think that that's all relatively straightforward. You understand how adding properties to this file essentially gets them generated in the database for you. I don't think anybody struggled with this particularly. Other things to note in this file that I've added, though. I've used the constraints to say that course code has a max size of 20. Now, there's a constraints block here. There's also a mapping block here. The difference between the two are the constraints are often used at runtime. For example, when we generate forms, the framework can auto-generate verification and validation rules for us. That's what the constraints are used for. They're often fed back to the user as you can't save this record because you don't meet the constraints. The mapping section, on the other hand, deals with how the framework is going to generate SQL and tables based on the contents of this class. And here you can see that I've used this special mapping to change the table name to course. Actually, I think course is what it's mapped to, but this allows me to change the table name if for some reason I want to avoid a name clash, or I've got an existing table I need to map onto. And then what I've done is, for course name, I've set the column to course underscore name, which again I think is what it would have been. However, course code, in the database originally would have been mapped to just course underscore code, but I've said actually I want this column called mapped course code, and if we look in the table you'll see mapped course code there. So you can see how we can change the database schema using this mapping section. Now, lots of things in Grails, particularly with the domain classes, we have to separate out what are properties of the class and extra information that we're giving the framework so that it knows how to talk to a database. So usually where you've got these static blocks, you're saying here's some extra information about this class which isn't necessarily a part of the class itself, but is information the framework's going to need to be able to do its work in essence. So the final mapping thing I wanted to point out to you is you can see that these varchar columns by default, apart from where I've set the size explicitly, they have a length of 255. Obviously I've got a description here, so a course description is likely to be more than 255 characters, and in fact what we really want is some kind of large text field or lob field. I think you'll have in Oracle lob objects. So what I've done is I've also not only changed the column name for the description property, but changed its type to be text as well. So the thing to take home here is we've talked quite a lot about convention over configuration. So all these fields have default types, and in a very real sense, we could have had a class which didn't have any of this in it and just consisted of these 4 properties, and that would still have worked. But what we're doing is we're using this mapping to start to override the conventions by saying, actually, I'd like a few things mapped differently to the default. So here, as I said, this is changing the type to be text. So that's all about mapping simple properties. The next thing that we had to do was, if we look at, let's have a look, a class. So this would be like the Monday afternoon web architectures class. Okay, that class has an instructor and is an instance of a particular course, web architectures. So here what I've done is I've got a property, but instead of it being a simple string value or a date value or an int value, this particular property points to another class. So in this case we have an instance of class instructor. So this is how we do the one part of the one-to-manys. This is how we point to a particular row in a different table. So in essence, what I'm doing here is my reg class table is going to have a foreign key to the instructor table, and you can see in the mapping section again what I've done is I've said actually the column name for instructor, rather than have class underscore instructor, which is what the default would be, I've overridden it to say actually let's call it instructor FK because it's a foreign key into the instructor table. So this is a slightly different this is in essence an association where we point directly to the instructor class, and we've modelled it just by adding the class name and then giving it a variable name, and then down here we've used the variable name in a mapping to say actually when you generate the database don't call it class instructor, call it instructor FK. So that's reg class, which of course will have come to us reg underscore class in the database. If we describe that table, you'll see that we've now got an instructor FK. So if I wanted to find all the classes that were being taught by instructor 1, of course, I would say something like select star from reg class where instructor FK equals, if the foreign key were 1. And in actual fact, when we look at the instructor, in fact let's do that now. The final property type that we wanted to do, so we had associations that were pointed to individual rows. The other part of the association is where we have collections, and in this case we've got a set of classes. Now what I've done is I've made it explicit. I've said there's a property called classes. A property called classes, which is the set of all classes taught by this instructor. Now there are 2 things going on here. Somehow the framework needs to be able to execute SQL exactly like this, where we find all the classes being taught by a particular instructor. right now, all we've done is to say this is a set called classes. We've not told the framework what that set contains or how it should populate that set. So what we're doing is we're using a little bit of static metadata here, and we're using the hasMany annotation, for want of a better term, and we're saying actually the set called classes really is a collection of reg class instances. So this is the telling the framework essentially which table it needs to join to in order to be able to populate this set. Now, that's actually not enough, because if we look at reg class, of course, it's got all these fields in it. So it's got a course foreign key, it's got an instructor foreign key, and actually, as far as the framework's concerned, these are all just columns. So what we need to do is we need to use this mapped by annotation as well, and what we need to say is, oh, by the way, that set of classes as well, when you do generate the SQL, the property in the remote instance that you need to join on is class instructor. So what that does is that essentially tells the framework that this is the foreign key it needs to join when it's doing that SQL. So what we're doing is we're telling the framework how it can start to construct SQL behind the scenes. So if you remember in class when I talked about this object relational impedance mismatch, which is the problem that object-oriented structures don't always break down particularly well into relational structures. This framework is trying to work around that for you by generating lots of SQL, so you don't have to write all the SQL to go and collect all the courses which an instructor teaches. The framework's generating that for you. But the price of that is that we have to tell the framework where it can do its joins and what properties need to be brought back. So this is all about how we tell the framework how it can generate the SQL. Now, so what I've done is I've pretty much populated all these classes, and you can check this out and have a look. But what I've also done is some of the classes have got these to-do blocks in them, and what I've said here is reg class. So this is an instance of a class like Monday Afternoon Web Architectures class, yeah. If you remember in our domain model, which was this thing, a reg class, we called it reg class, remember, to avoid namespace clashes. A class has many registration sheets, is that right? Yeah, sorry. And it also has many enrolled students. So if you come to the Monday Afternoon Web Architectures class, then you as a student are enrolled on Monday Afternoon Web Architectures. So what I've said is, for reg class, there's obviously a set of enrollment objects, which is the set of students who are enrolled on the course. Now, I've left that blank, so you're going to need to, I've put the set in there, enrolled students, but you're going to need to fill out these hasMany and mapped by annotations. Obviously, there are lots of others about, so you can just look at the form. All you need to do is to figure out what has to go in there, and I've tried to make it pretty obvious with the text here, what they should be. So even if you've not made much progress on filling out these classes, there are a few to-do exercises. So that would be one of them. You've got to fill out a set property and tell the framework how to map it. Let's go for the next one. Yeah, so register entry, which is this one here. So if you remember, we could have used a many-to-many relationship between student and registration sheet. So this is you in the act of on Monday the 28th, for example, signing the sheet to say, yes, I've attended Web Architectures at 4 p.m. That would be a register entry in this model. And we could have used a many-to-many relationship, but we've chosen instead to have a very traditional link table in essence, but in the object model as well. And the reason we've chosen to do that is there are probably going to be properties we want to store at this level, and it's useful to be able to refer to this relationship in its own right. So for example, the time the register was signed, and we might want to do some other kind of fingerprinting to prove that it really was you and not just somebody signing it on your behalf. I don't mean real fingerprinting, electronic fingerprinting if you like. So we've got this class. And what I've said is, actually, I've put the student property in here. So this is an occurrence of a particular student signing a particular register. So we've got the student part, but we need the register being signed part. So this is going to be one of those, let me find an example. yeah, this is going to be one of those really simple sort of scalar properties. Or it's an association, but it's an association to another object in the domain model rather than a set or a collection. So register entry. So what we need is like this, but instead of it being a student, it's going to be a registration sheet, and we want the properties to be called reg sheet. And if you could as well, use the mapping to change the column name to reg sheet fk. So that's kind of you having a go at setting up an association which has a single value pointing to a particular registration sheet. And the last thing is the registration sheet itself obviously needs to have a set of signatures. So this would be, the 15 students who signed the sheet for Monday afternoon class. So in here, I've already set up a property called set signatories, but you're going to need to set out the has many and mapped by metadata so that the framework knows how to map the particular signatories to a registration sheet. So this is what's going to let us see who attended the class on the 28th of January, for example. So hopefully none of that should be news to you, and there's just a few little exercises for you to just validate your understanding is okay. You can drop me an email, or you can catch me next week in class if there are any questions about that. Obviously, once you've done this, if you wanted to run the application, then you can have a look around it. It's important that you get a feel for how the object model maps onto a particular database schema, because obviously that's the key here. Is we're trying to make it easy for our domain model to be mapped into a database structure, but you still need to be familiar with the database structure and understand what's going on there. So that's a recap of where we got to after the last two lectures, and as I said, either catch me in class or email me if there are any questions about that. Okay, I'll do another screencast for the next part, which is going to be starting to look at controllers. Hopefully we've got the data model part down now, so we'll move on to something more interesting. Okay, thank you.